For this presentation, we'll be focusing on chapters 7 and 8 in Robert Glennon's book, Unquenchable. At this point in the book, Glennon has already established America's water crisis, and now he begins to present a variety of potential solutions. We will be focusing on the real and surreal solutions proposed in these two chapters, some of the obstacles related to these methods, and many of Glennon's rhetorical tools he makes use of to get all his readers on board. Presenting on Glennon's chapters is our team, Taylor, Adams, Sable, and our man Glennon. Please have your Unquenchable book handy for the discussion at the end of this presentation.
Let's begin at the bottom, with Glennon's underground look at the Colorado pipelines. Glennon perfectly sums up this approach on page 137 as an engineering mentality that assumes there must be a technological fix to water shortages. There's no need to live within our means to tailor land use plans to the available water supply, because an engineering solution can solve the problem and allow growth in unsustainable water practices to continue a while longer. A Colorado-based businessman, appropriately named Mr. Million, has a 4,400,000,000 privately financed vision. He wants to divert 165,000 acre-feet of water from Flaming Gorge Reservoir in Wyoming and Utah along Interstate 80, where it would cross state borders, scale a variety of elevations, and provide water straight down the center of Colorado State, the main artery into the heart of Colorado. Glennon doesn't shy away from the massive list of complications that stand between Million and his dreams of privatizing water he believed he has a right to own. To summarize a few obstacles Million faces are the immense cost, complicated environmental compliance, daunting engineering challenges, uncertain legal rights, political opposition, and institutional barriers. Let's not forget about the Upper Colorado River's pike minnow. This endangered species has the ability to derail plans for a pipeline if the environmental impact of diverting water from its habitat proves to be detrimental. Million's proposed plan to divert 165,000 acre-feet of water from the pike minnow's habitat have been met with opposition from the Wyoming Water Development Commission and the Utah Water Conservation Board. Without the environmental compliance, Million could not gain the permit from the Bureau of Land Management or the contract from the Bureau of Reclamation. Glennon's rhetorical routine relies on the logos method, which is logical reasoning from support using claims, credible sources, facts, and figures. He distinguishes the severity of the hoops Million must jump through by name-dropping head honchos such as the Bureau of Reclamation, the U.S. Bureau of Land Management, the Wyoming Water Development Commission, Utah Water Conservation Board, to name a few.
So let's rise up from the depths of underground excavation and look up towards the sky as we investigate Glennon's second surreal solution, cloud seeding. While researching a solution to the water shortage, Glennon investigates a process of cloud seeding. So what is cloud seeding exactly? Well, about 20 years ago, a highly regarded scientist developed a hybrid seed. This seed could be planted into fertile soil and sprout highly condensed rain clouds. These rain clouds can then provide water for farmers' land without having to install intricate irrigation systems. Okay, I totally lied. There's no such thing as a plantable cloud. So what exactly is cloud seeding? The idea behind cloud seeding is to induce rainfall with the aid of human intervention. Using radar analysis, scientists seek out clouds with a high enough moisture content to potentially produce rainfall. Then they fly airplanes above the cloud and disperse chemicals, usually silver iodide or frozen carbon dioxide, into the cloud with the hope of inducing rain. Seems simple enough. However, Glennon touches on a few obstacles that seem to prove otherwise. Obstacle 1. There is no convincing scientific proof. Here's the problem. Let's say a plane spreads silver iodide into clouds above Fresno, California. A few hours later, or even the next day, it rains. Did the seeding cause the precipitation? Perhaps it would have rained anyways. Did the seeding increase the amount of precipitation? Perhaps it would have rained just as much without the seeding. Conducting the scientific method isn't possible because you technically can't have a control group or multiple trials with the exact same circumstances. It's not like we can control the weather or anything. Obstacle 2. Even if cloud seeding is effective, it falls down to politics. Who gets the water? If Joe Schmo is seeding the sky and his neighbors downwind reap the rainfall benefits, there's a lack of clear property rights to that water. And obstacle 3 is the potential liability. The potential liability of causing floods or avalanches should the seeders succeed too well, not to mention the potential liability for increasing air and water pollution by the intentional release of toxic chemicals, silver iodide, into the atmosphere. So what types of rhetorical devices does Glennon draw on when making a case for cloud seeding? In Cox's article, he defines the two basic functions of discourse: a pragmatic approach, which is designed to educate, alert, mobilize, and persuade others, and a constitutive approach, which utilizes language and symbolism to shape readers' perception. When reading the chapters, you'll notice that not once does Glennon blatantly disagree with cloud seeding. Let's take a look at a few examples of this language that directs the reader's perspective. The cloud seeding field has had more than its fair share of charlatans. The key word here is charlatan, which is also known as a swindler, a person practicing quackery or some similar confidence trick in order to obtain money, fame, or other advantages. New efforts to secure federal appropriations have sometimes used fear-mongering as a tactic. Fear-mongering is the use of fear to influence the opinions and actions of others towards some specific end. And an excerpt from the book reads, in the 1960s, the United States military in Project Storm Fury tried to diffuse hurricanes over the Atlantic Ocean through cloud seeding. They may have succeeded in changing a hurricane's shape slightly, but only briefly, and the project ended when scientists realized that cloud seeding might perversely increase the hurricane's ferocity. During the Vietnam War, the military's Operation Popeye sent $21.6 million on cloud seeding to try to slow the movement of North Vietnamese trucks by turning the Ho Chi Minh Trail into mud. We still lost the war. And one more example involves Glennon's pessimistic vision of cloud seeding's future. Amongst all his research, Glennon appears to remain unconvinced, categorizing cloud seeding as truly a surreal solution. So now let's take a look at Glennon's final scientific solution, which involves the largest quantity of water known to man, the ocean, and the massive desalination monster. What? Sorry, ready to do it. What is desalination? Desalination is the process of removing salt, especially from seawater, so that it can be used for drinking or irrigation. The two principal technologies in use today that desalinate ocean water are distillation and filtering. Distillation mimics what the sun does to the ocean by evaporating the surface water and leaving behind the salts. Filtering allows water to pass through but blocks the passing of salt. One technique of filtering is reverse osmosis, which uses pressure to force water through semi-permeable membranes, leaving the larger salt ions and some salt-laden water molecules behind in concentrated brine. However, both of these desalination solutions to the water problem face staggering obstacles. Firstly, the desalination monster earns its name not just because of the size of the facilities, but also because of the massive amounts of energy it consumes. It takes a large quantity of water to produce a single kilowatt of electricity, and it takes megawatts of electric power to run a desalination plant. And of course, energy comes from fossil fuels, which in turn increases greenhouse gas emissions. Distillation quickly causes the wearing down of components, more specifically, the fragile membranes of the filters. Replacement parts and constant maintenance drive up the operation cost. Glennon says,
but if money and energy are limitless, distillation is an option. Another difficult obstacle involves the type of waste the plants produce. Desalination plants produce a discharge that has double the salinity of normal seawater. Disposing of the brine back into the ocean causes significant problems to the environment. Seawater isn't just water, but a habitat for numerous organisms and sea life. The sea serves a critical role in everything from the food web to the climate. Putting it into perspective, every 100 gallons of seawater will yield 15 to 50 gallons of potable water, and leave 50 to 85 gallons as a supersaline byproduct. While Glennon states that desalination is an interesting proposal, he also says it is an emerging technology, not a magical solution to the problem of water scarcity. Don't expect to see homeowners water their lawns or farmers irrigating alfalfa fields with desalinated water anytime soon. And it has great potential and always will.
Glennon's word choice portrays millions pipeline, cloud seeding, and desalination plants as surreal solutions supported by real efforts. His arguments lean against the idea that the effectiveness of the engineering and scientific interventions are entrepreneurial dreams held up primarily by faith rather than fact. Specifically in the chapter, Glennon compares people's scientific belief systems to that of a religion. Phrases describe the people who doubt the effectiveness or feasibility of these methods as agnostic. There is a notion that these believers associate with the Church of Weather Modification Association. The theme here revolves around the faith in these solutions. Faith is believing without seeing the results. Additionally, Glennon pulls the line, "Rob Peter to pay Paul." The etymology behind this phrase is its reference to times before the Reformation, when church taxes had to be paid to St. Paul's Church in London and to St. Peter's Church in Rome. Originally, it referred to neglecting the Peter tax in order to have money to pay the Paul tax. It can apply to situations when solving a problem in one way that would make another problem worse off, basically producing no net gain. So please get together in a group of about 5 to 8 students and look at some of the religious references in this chapter that we have listed up on our presentation. How does Glennon's use of religious diction and references enhance or decrease the strength of his arguments? Now, in your groups of 5 to 8 students, turn to pages 135 and 147. Read the title and the epigraph at the beginning of each chapter and answer the questions below. How do Glennon's chapter titles and introductory quotes prepare the reader for the chapter to start or shape their opinions of what they're about to read? Above are 2 definitions used in the chapter titles, alchemist and laminate. Feel free to use those when you're discussing your ideas. Right on.